everyone, how are you doing? Welcome to an algebra tutorial video learning about how to factor out the greatest common factor from a polynomial and then rewrite it. So here we go. We've got 12x squared minus 9x. I got a binomial here. And then we've got a trinomial, 14a to the fourth plus 21a to the third minus 7a squared. We're going to factor both of these, find the greatest common factor, and then rewrite it in factored form. All right, first thing I need to do is look at, well, out of both of these terms for the binomial, what is the greatest common factor? Well, I'm going to start with the 12 and the 9, my number part, and the 12 and the 9 both have a factor of 3. All right, so we're going to write that down. There's a factor of 3 in both of these. Now, that we move to the x part. I got x squared and an x. So in common, I have one factor of x in both of those terms. I have two x's in the first term, but only one in the second term. So in common, there's a factor of 1x. So the greatest common factor then, greatest common factor is equal to 3 times x. I combine both the number part and the variable part. All right, so now how do we rewrite this? Well, I need to do some polynomial division. I'm going to take my 12x squared minus 9x, and I'm going to do the opposite of the distributive property. Instead of multiplying, I'm going to divide out the greatest common factor. So I'm going to divide out 3x and see what I have left. So 12 divided by 3 is going to leave 4x, or 4. X squared divided by an x leaves an x. So I'm using my polynomial division stuff. Minus 9 divided by 3 is 3. And x divided by x just leaves just 1. So 3 times 1. So that's what I have left. But I have the greatest common factor portion that I divided out. So I need to say it's in front. I divided it out. It was in common with both factors, but I divided it out and separated it in front. So now there we go. I took 12x squared minus 9x as a binomial, found the greatest common factor of 3x, divided it out of both terms and set it in front with a parentheses indicating that that 3 times x used to multiply the 4x minus 3, but I factored it out. So now we have two factors. We have 3x multiplied by 4x minus 3. So we've turned our original polynomial, our binomial here, into two things multiplied together, which is factoring. And if you want to check your factoring, if you're not sure you did it right, or you're feeling a little sketchy, just multiply it back together. Use the distributive property. Does 3x multiplied by 4x minus 3, does it distribute back into 12x squared? So 3 times x times 4 times x, multiplying those first two terms gives me 12x squared. 3 times 4 is 12, x times x is x squared. But then I distribute it to the minus 3. 3x times negative 3 is negative 9x. And it checks, I get right back to where I started with. So you can always multiply to check your work in that you're factoring correctly. All right, but there we go. There is my first solution. I rewrote the original polynomial in factored form by factoring out the greatest common factor. All right, let's take a look at another one here. Let's look at my trinomial. So I've got three terms. Looking at all three terms, I want to find the greatest common factor. Start with 14, 21, and 7. Well, they all have a factor of 7. 7 goes into 14, 21, and 7. Now if I look at the number part, we have a to the fourth, a to the third, a squared. There's a factor of a squared in each one of these. So in this trinomial, my greatest common factor out of all three terms is that they all have a 7a squared. I can divide that out. It's in common with each of these three terms. All right, now let's separate it and rewrite it out. So we got 14a to the fourth plus 21a a to the third minus 7a squared. And I want to see what do I have left after I factor out the greatest common factor. So I'm going to divide by 7a squared for all three terms, because all three terms have those factors in common. And let's rewrite what we have left. So 14 divided by 7 is going to be 2. A to the fourth divided by a squared leaves a squared. Plus 21 divided by 7 is going to be 3. A to the third divided by a squared is going to leave just 1a, a to the first. And then minus 7 divided by 7 is 1. A squared divided by a squared is 1. They're the same exact thing in the numerator and denominator, so it just leaves 1. Now, however, I factored out a portion, right? I have to rewrite the trinomial. That's what's left after I divide it out. So I put the 7a squared in front, indicating that it used to be in common, but I factored it out, but I still need it to be an equivalent trinomial. 14a to the fourth plus 21a to the third minus 7a squared is exactly the same as this. It's just in factored form now. But let's go ahead and check. If I want to check, I can go ahead and distribute it. 7a squared, if I multiply it all back together, plus 3a minus 1, let's check. 7a squared times 2a squared, yep, that's going to be 14. 7 times 2 is 14. A squared times a squared is a to the fourth. 7 times 3 is 21. A squared times a is a to the third. And 7a squared times 1 is going to be just 7a squared. Yep, that matches with what we started with, so I multiplied it out and checked. So I'm feeling pretty good that in factored form, if I factor out the greatest common factor, this polynomial, this trinomial here, is equivalent to this trinomial here. This is just in factored form. I factored out the greatest common factor. All right, hopefully that is helpful for you guys. Again, as you're getting into algebra, as you're getting into polynomials, we want to be able to take polynomials and rewrite them in different forms. Factoring is just the skill that allows us to do more complicated math later on.